So welcome everybody to what is, I think, our maybe 11th-ish session of this Lunar Surface Science Workshop. Today's session is on progress and challenges, updates from NASA headquarters in Artemis. So we've been doing this for about a year now. We have gotten really great input from the community on an array of topics. And we thought maybe it was time for us to give some input back and show you guys what we've been doing for the last year and where we've come and where we're going with Artemis. So we're very excited to be here. I think we've got a great lineup of talks today. I will say that we have recently updated our website. So all of the talks from all of the previous sessions are available at the website, and somebody can probably post the website in the chat so you guys can get the link to it. It's much easier to navigate now. We recently put up the draft reports from our last 5 sessions. And so if you have interest in those, I highly recommend you go and take a look and provide us feedback on those drafts. Just a quick look at the session, the sessions we've had previously, our next upcoming session. So we're going to take a little break for the summer. We'll be back in August with a session, another joint session with the physical sciences folks. We did the space biology one in January. Now we're hitting up the other half of BPS with the physical sciences folks in August. We are planning for a heliophysics one in the fall as well. So some things to look forward to, but we're going to take a break for August. Or until August, we thought you could all use a little break. I know we could. So we're going to take a little bit of a rest. But I'm going to turn it over now to Jake to get started for today.
All right. Hi, everybody. And thanks, Sarah, for getting us kicked off there. So it's a pleasure to begin the discussion today as we're talking about how we're going to explore the moon and beyond. And I think we discussed this morning, I think it would be very fitting to acknowledge the passing of one of the pioneers in our community, Michael Collins. I think we could spend the entire session today talking about Mike's impact on everything we do today. And I think really there's not much more that we can say. His life, the way he lived his life explains it. So I'll just give some of his own words as we get kicked off this morning. It's human nature to stretch, to go, to see, and to understand. Exploration is not a choice, really. It's an imperative. I think those words from Mike are important for us to keep in mind, and we thank him for his service. We hope he rests well, and we pick up the torch and we carry it on, and that's what we're all here to talk about today. So the rest of the session today will be focusing on updates from NASA personnel and discussing the direction we're taking and what we're doing. We did this about a year ago when we kicked off the Lunar Surface Science workshops. And so as Sarah mentioned, it's a good time to come back around and discuss where we are today. And so I'm thrilled to be able to hand off now to NASA's acting administrator, Steve Jurczyk. So he can start right from the top and talk about what NASA's up to and where we're going. So Steve, off to you. Thank you.
Hey, thanks, Jacob. And yeah, I want, as Jacob mentioned, we do stand on the shoulders of giants, and Michael Collins was one of them, and just an outstanding contributor, an outstanding ambassador for NASA, and just an outstanding person. So we won't miss him. So thank you for inviting me to join you and talk to you today. We've had a pretty exciting year at NASA. It's been very challenging, obviously, with keeping our missions moving forward during a global pandemic. But I'm really proud of the NASA team with our industry and international partners. We've made incredible progress on our long-term goal to send humans to Mars through our commercial crew program, which is enabling us to have 4 crew regularly on ISS and do more science, both for science and technology development, both for applications here on Earth and to advance our deep space ambitions. And all the systems needed to advance our Artemis plans and our Moon to Mars approach are are underway. So it's also really exciting to hear early on in the Biden administration, and in addition to the bipartisan support we have from Congress, the support for the goals of the Artemis program. We talk a lot about constancy of purpose and the importance of it, and I believe we have that in the transition to the Biden administration and unqualified support from them. Our goals 50 years ago were to prove we could land humans on the moon, return them safely to Earth, and this time our goal is to return to the moon in a sustainable way and establish a sustainable presence, which is key to preparing for greater achievements and pushing human presence out into the solar system. We'll use the moon to validate deep space systems, technologies, and operations before embarking on a human voyage to Mars. So throughout the 2020s, the Artemis program will lay the foundation for a sustained long-term presence on the lunar surface. And the way to do this is to work together. And I'm really proud of the agency and the agency leadership in having a well-integrated plan for Artemis across human exploration and operations, science, and space technology. And we've been working for a couple of years now on establishing that integrated plan and putting more detail in it and playing it out through the 2020s. Again, I mentioned the agency has all the critical systems in development with our industry partners and international partners, and that will help ensure we return to the moon as quickly as possible and establish a sustainable exploration around and on the moon by the end of the decade. Space Launch System rocket, Orion spacecraft, Human Land System, and the Gateway are the backbone of our deep exploration plans and key to our Artemis goals and objectives. Recently, NASA selected SpaceX to build what we're calling a kind of 21st century human landing system that will transport astronauts from lunar orbit to the surface and back. And this week, the core stage of the Space Launch System arrived at Kennedy Space Center after a very successful hot fire test at Stennis. And actually, I've been getting pictures and text messages of the core stage being offloaded from the Pegasus barge, and it'll make its way over to the vehicle assembly building, and all the hardware for SLS, Orion, along with the ground systems, will be at Kennedy and will undergo integration for the Artemis 1 mission. Schedule is really challenging right now to launch Artemis 1 this calendar year, but we'll track the key milestones in getting the vehicles integrated on the mobile launch platform at Kennedy, and hopefully we'll hit those milestones and we'll be on track for a launch of Artemis 1 by the end of the year. And then we're in the manufacturing, integration, and test for SLS and Orion for Artemis 2 mission, the crewed flight test of Orion and SLS in 2023. The agency is reviewing our Artemis plans to ensure the program can be implemented as quickly, efficiently, and effectively as possible within our budgetary constraints and assumptions on the budget that we have. The goal of the internal review is to evaluate the current Artemis program budget and timeline and develop high-level plans that include the content of the missions beyond Artemis 2 and the schedule and budgets that go along with that. So we're in the coming weeks, we'll wrap that up and look forward to briefing our new administrator, Senator Nelson, when he gets confirmed and comes on board, and that'll be part of our budget plans moving forward. So with SLS and Orion, as well as our commercial partnership on Human Landing System and the Gateway, we'll send astronauts to the moon and provide the opportunity to develop and prove out the technology, systems, and operational capabilities we need, not only for sustained lunar presence, but that feed forward to Mars. We'll build key, we're looking at building key surface infrastructure on the moon for sustained presence at the lunar South Pole, anchoring a lunar development zone that enables science investigations, technology demonstrations, and potentially economic activity. So a lunar terrain vehicle, or LTV, would transport crew to areas that would be difficult to reach without a vehicle like that around the landing zone. We're looking at potentially an international partnership on a habitable mobility platform, or what we call a pressurized rover, which would enable crews to venture farther from that base and extend surface missions to 45 days. And then we're looking at the requirements and how we would implement a lunar foundation surface hab that would house 4 crew members and also extend stays on the lunar surface. Astronauts working on the lunar surface can test advanced robotics as well as a wide set of new technologies identified in the Lunar Surface Innovation Initiative, focusing on development in areas including in situ resource utilization and power systems to support those ISRU capabilities. It was really exciting. We actually did the first ISRU experiment on another planet a week or so ago with Mars oxygen in situ resource utilization experiment on Perseverance, or MOXIE, where we generated oxygen from atmospheric CO2. So that was our first and a really exciting accomplishment. Congratulations to the Space Technology Mission Directorate and JPL and their partners on that, on being able to demonstrate ISRU for the first time. Rovers will carry a variety of instruments, including ISRU experiments that will generate information on the availability and extraction of usable resources like water. So we have the Viper mission, which is our first exploration of the frozen water and permanent shattered craters, how it's bound with the regolith or Martian lunar soil, and how we could exploit water for potable water, food, and oxygen to enable sustainable surface operations. And ISU is absolutely an enabler for a human mission to Mars. Our commercial, we've always said Artemis, key to Artemis was our partnership with our U.S. commercial partners and our initial partners. Gateway is a part of a key part of our sustained presence around the moon, and we had a key decision point review at the agency level, kind of equivalent to moving into phase B for the Gateway. For the first configuration of Gateway. So that's the power and propulsion element, the habitation and logistics outpost, and then we'll build on that with the robotic arm from Canada, the IHAB, which is a partnership between ESA and JAXA, and then the Esprit, or utilization module, with ESA. So really great international collaboration on the Gateway. The Gateway provides a staging point for human and robotic lunar operations, as well as an observation platform, particularly for things like space weather. As the Gateway capabilities grow, NASA and its partners will boost the science and technology demonstrations on orbit, as well as on the surface. And again, the Gateway also enables increased mission durations on the surface, creating an opportunity for longer stays and multiple surface expeditions deployed from the Gateway. The first human mission back on the moon will last approximately 7 days, and NASA plans to send the Artemis generation astronauts on increasingly longer missions about once a year thereafter, conduct missions both on the surface and on the Gateway. Also, I want to mention commercial lunar payload services. It's absolutely a different way of conducting missions, and in this case, missions to the lunar surface. And we're hoping by the end of this year or early next year to conduct our first two missions with astrobotics and intuitive machines. It's turned out to be a great way not only for NASA to deliver science instruments and technology demonstration payloads to the surface of the moon, but also in commercial partners and even international partners. So I'm looking forward to the first two CLIPS missions, hopefully later this year. So it's an incredibly exciting time. NASA is closer today than at any other time in our history since the Apollo program to returning astronauts to the moon. We'll start with our robotic landers later this year, and we're hoping to land about 2 robotic deliveries to the moon each year. We're not only, like I said, not only for NASA, but opportunities for others to have science and technology payloads on those landers. Yeah, and it's just really exciting actually to have the human landing system in development. It's the first time we've had a human landing system in development since Apollo. So while human exploration of Mars is possible in the coming years, NASA is developing. We're going to develop the many technologies and capabilities needed to send humans farther into the solar system. And we can do it. We can, but our work at the moon will prepare us for that next giant leap of sending astronauts to Mars. So yeah, thank you for the opportunity to speak with you today, and we look forward to continuing to work with you all, the entire community, to put the first woman and the first person of color on the moon. So thanks for the opportunity to speak to you this morning.
Thank you so much, Steve. As Steve just mentioned, he talked about human exploration, spacecraft, the architecture we're developing. He talked about scientific experiments and activities on the moon. He referred to space technology demonstrations, all of this being critical towards implementing the infrastructure that will enable us to explore the moon. And to that point, it's obvious that this is something that touches on multiple mission directorates at NASA. It's relevant to in multiple locations.